All right, our second example is asking us to determine the same thing as the first, the constant of the proportionality based off of this graph. So we're going to look at our axes, and the x-axis is also talking about days of vacation that Kira has taken, and our y-axis is talking about the number of postcards that she bought. So I want to know, how many postcards did Kira buy per 1 day of vacation? So I can use this ratio once again, that k, or the constant of proportionality, is equal to the ratio y divided by x. So I need to determine what my y and what my x value is. So I look at my graph and I realize that the line is going through the origin and that it is a straight line, so I know that it is proportional. And I'm going to look for that point on the graph, or one of the points on the graph, that goes through a corner. Like I said in the first example, there's more than one that go through the corners, and it doesn't matter which one you choose, you just have to make sure that it goes through a corner. So I'm going to choose this point up here at 3, 9. And remember that our ordered pair is x, y, so this point is at 3, 9, but in my ratio, I want y divided by x. So k is equal to y, which is at 9, divided by my x, which is at 3. Now, this relationship is saying that Kira's purchased 9 postcards in 3 days of vacation. Now remember, with constant proportionality, we want to know what k is when we have a denominator of 1, so per 1 day of vacation. So if I simplify this, I get k is equal to 3 divided by 1, or k is equal to 3, which is telling us that Kira purchased 3 postcards per 1 day of vacation. Our third example is talking about pages that Nicole has written in a number of hours. So our x-axis is the hours that Nicole has spent writing, and our y-axis is the total number of pages that Nicole was able to write. So we want to know how many pages Nicole wrote in 1 hour she spent writing. So we still have our ratio, constant of proportionality, or k, is equal to y divided by x. I look at my graph and I realize it is a straight line that goes through the origin, so it is proportional, so I'm able to use this ratio. And I want to find one of those magic corners where the line goes through evenly. So I'm looking at the graph and I see that this isn't quite through a corner. This is not through a corner, but I have a corner right here. This point right here goes through a perfect corner. So that ordered pair is at 40, 50. So x, y, it's at 40, 50. But in my constant of proportionality, we remember that we need y over x. So our k is equal to our y, which is at 50, and our x, which is at 40. Now, this is telling me that Kira has written 50 pages in 40 hours. Now, I want to know how much she was able to write in 1 hour of writing. Now, 40 doesn't go into 50 evenly, but I do know that I can simplify this by 10. So I can simplify this to k is equal to 5 divided by 4. Now, that's 5 pages of writing in 4 hours. But my denominator is still not 1, it's 4. I need this to be pages per 1 hour. So I need to divide by 4. 4 divided by 4 is 1 hour, but what I do to the bottom, I have to do to the top. So I end up getting k is equal to 5 divided by 4, which is 1.25, divided by 1, or 1.25 pages per 1 hour of writing. Now I have a constant of proportionality where my denominator is in fact 1. Now I left it as a decimal. You might leave it as a fraction, but because we need this denominator to be 1, I'm leaving it as a decimal. So my constant of proportionality here is 1.25. So Nicole is able to write 1.25 pages for every hour that she spends.